So, hello Akansha, hello Sachin. We are into a very interesting part of our lesson, that is numericals for mirrors. Now, first of all, to recall, I'll try to put place a diagram, ray diagram, which you had learned. Suppose the object is kept between F and C, then the image formed is inverted and it is real in case of concave mirror. And here, when the object is kept between pole and focus, see, this is the object, the image is virtual, it is magnified. Normally they show virtual images by dotted lines. Alright, now once again, may I have your attention, always be looking on the screen, zoom it and try to see. So this is the case where this is the ray diagram. Now ray diagram and numericals, they both complement each other. So now see, there is one case when the object is above and the image is inverted. Here the object is erect and the image is also erect. So there must be some sign convention to distinguish between them. So first and the foremost thing to do of physics numerical on mirror or lens, we have to understand the sign convention. And we will follow the rule which, there are many rules. You follow the rule which I am telling you. There won't be any problem later. So the first thing is that how the image is formed. Ray come from the mirror, from the object towards the mirror always. So the direction of flow of ray is from object towards the mirror on the reflecting side. Number one. So that the sign convention is based on the direction of the incident ray from the object. Rule 1. Every time whatever you have to measure, you have to go and start it and begin the measurement from pole. Rule number 1. And rule number 2 is very simple. If you are measuring in the direction of the ray, that means ray is coming this direction, so you are going ahead of the pole, then it is that the sign is taken to be positive. But if you come back, because you have to go to the pole and you have to measure back, then it is negative. If you are going ahead, suppose you have to go ahead of the pole, that is in the direction, the ray is moving this direction and you move further on the same direction, then it is always positive. So that is the most important part of sign convention. Now what are the distances of our interest? First is the focal length, f, distance between f and p, and it is denoted by small f. Second is the object distance, how far the object is from the pole, always from the pole. Yeah, I'll tell you, for anything, always start the alphabet P. Focal length is PF, object distance is, I'll put here U, so object distance is PU, like that. So from P you have to start, you cannot go FP, you have to go PF. So now let us use this, apply this. Suppose in this case I am telling the focal length is 8 centimeter. So I'll go here and measure it, 8 centimeter. Plus or minus?
Plus.
No, it is just the opposite direction. It is just the opposite direction. You are going in the opposite direction. See, ray is coming this side and you are going back. So it will be what? Minus. Now in this case, what will be the focus? You have to again go to the pole and measure. So here it will be what? Plus. That means you can even put it in your memory. Focal length of a concave mirror is taken always as negative. That means if the focal length is given 8 centimeters, so the value of f will be minus 8. And if the focal length of a convex mirror is taken as positive, suppose they say focal length is 12, then it will be taken as plus 12. You should write plus 12 in your answer. Now the object distance, suppose I am again asking Sachin, the object is at a distance of, say for example 25 centimeter, plus or minus? Minus. Very good, it is minus because from pole you have to measure. Look at the pole, from pole you have to measure, pole to the object. So here also suppose it is 8, suppose the distance is 8, now this is object distance. So from pole I am starting, what should be it? Minus 8, good. So that is there. So object distance always in the whole chapter of 10th, it should be negative. So object distance, you don't have to get confused at all. Whether you use or don't use the formula or the sign convention, you will be negative. This you should remember always in your mind. F changes, F for concave mirror will be, since I am going back, what it will be? Negative. And for the convex mirror it will be positive. So that is the most important. Now there is a relationship, mirror formula, 1 by V plus 1 by U is equal to 1 by F. and the magnification formula is minus V by U. Magnification I am not teaching you, through the numerical I will teach you magnification. So I am putting one numerical over here. I will take this incident first in form of a number. I am writing the question 1. Find the image distance. Find the image distance and image nature. Nature of image I am writing short. Image nature if an object is kept at a distance of 12 centimeter in front of a concave mirror of focal length 8 centimeter. So I am doing this numerical, I am doing this. I need I will rub off the board now over here to get some board space. So here we are now. Let us try to see what we can do. Now F, focal length, it is a concave mirror and U is given. I said you don't have to worry, always you have to take water. So here U is how much? It's written 12, the magnitude U will be minus 12. Now the type of the mirror is a concave mirror, that means this mirror. So focal length will be how much? Minus 8 centimeter and minus 12 centimeter. Very good, Akansha, very nice. Now we solve the problem. We have the formula here, 1 by V plus 1 by U is equal to 1 by F. So 1 by V will be equal to 1 by F minus 1 by U. Very simply we place in the values now. So minus 1 by 8 and there is U is 12 and there are two negatives, so it is positive. So the LCM comes as 24. So 24, 8 3s plus 12 2s. So V is equal to minus 24 because it will be 1 by V is minus 1 by 24. Now see, recall, you can rewind and see the diagram here. When the object was between F and C, the image was this side only. So the negative number is telling, you recall this, I will just draw it for you. The object is here because the focal length is how much? The focal length is 8. So center of curvature is 16 and the object is in between that 12. So the image is beyond C. So the answer should be more than 16. So it is 20 minus 24. And negative answer means this side. Because from pole if I measure, minus 24 goes this way. That's okay. Now the image is magnified and inverted. So here I will explain you what is M. And what does it show you? M is minus V by U. So negative the formula. Then V is again minus 24 and U is how much? U is minus 12. So minus minus cancel, 12 2s. So magnification is minus 2. Even it is an integer, convert it into a fraction. Equivalent fraction, that means divide by 1. Now remember, if there is a negative sign in magnification, that means image is always real and inverted. Real, inverted. First thing, the sign tells you negative sign means image is real and inverted, and positive sign means image will be virtual and erect. Second, if the numerator is larger than the denominator, then the image is enlarged or magnified. How many times? 2 times. If the object size was 6 feet, what was the image size? 12 feet. Very good. So that is the first case. Now we take another example of the second example. I will tell you what was the second example. So I will change the question a little bit. You all can pause and write down the question whenever you want, and then here we see. Let us have a look. There was a question, there was a figure like this, I remember. Image was between, the object was between F and P, and the image was this side. So I take this question into a numeral form. So find out the image distance and nature. If the object is kept at a distance of, I just change it to 10 centimeter, and this as, say for example, the focal length to be 20 centimeter, and we move on. Alright, we try to see. So that means focal length is 20 and the object is kept here between 10. My answer should be positive, isn't it? My answer should come positive because the image will be formed this way. So if I'm right, and if the relationship is right, we'll get to that. So let us see. We again put F is how much? It is a concave, so it will be minus 20. U will be how much, Sachin? Sachin, what will be U? Tell me, Akansha, what will be U? U is 10, so how much? Negative 10. Positive or negative 10? It is a concave mirror. It is a concave mirror. Concave mirror. Positive or negative? U. U, I said, don't worry about the mirror or the lens. U is always negative. Why? Because the rays come from the object, so you have to go back to measure it, isn't it? Always. So here, now let us see. Good. So 1 by F is equal to 1 by V plus 1 by U. So children, try to see. All the confusion I should be there, because we are playing that if there is something wrong, or so we are playing that intentionally somebody does wrong, and we correct it for your benefit, so that you can better understand that what are the confusions and where you may get confused. Very simple. You always, irrespective of the type of mirror or lens, place negative sign. So now what will happen? 1 by V is equal to 1 by F minus 1 by U. So okay, now 1 by U means it is 10 and both negative, now positive. So 1 by V is equal to 20. Now 1s are, so 1 by V is equal to 1 by 20. See, our answer is coming plus 20. Sachin, which side will be the image? This side? Yeah, it will be ahead. Very good. So it is positive, means it will be away, ahead of the pole. So our answer is correct. See, here also the situation tells object is minus because object is this side, and if it is plus, image is on the other side. That's very, very important. Now magnification. Magnification is negative V by U. Now M is equal to minus plus 20 minus 10. So minus minus cancel. Now see, it is plus 2. So plus 2 means image is virtual and rect. And 2 by 1 I do it. Now 2 by 1 means what? The image is magnified. Very good. So that is the first part. Thanks a lot. God bless you all.